Okay, I just started working this video and then my computer froze on me, so I'm going to re-explain what I just talked about and explain the problems we've already done so far. So this section is going to cover operations on radicals, which is section 7.3 in your text, and that can be found on page 584. On numbers 2 through 10, we are going to learn how to combine radical expressions when we have like terms. Numbers 12 through 24, we're going to learn how to combine these radical expressions when we do not have like terms. And then on numbers 34 through 66, we are going to learn how to multiply these radicals. Division is the other operation, which is on numbers 67 through 82. We do those problems in the lesson on rationalizing the denominator. If you would like to look at those problems, please visit that video. So on page 584, number 2 says 5 onto the square root of 6 plus 3 onto the square root of 6. So in order to combine these two expressions, or these two terms, we're going to have the same number under the radical. That number is called the radicand. So just like we have to have like terms when we're combining, when we don't have a radical, if we had 5x plus 3x, we could go ahead and combine those together to get 8x. Same concept here on number 2. 5 onto the square root of 6 plus 3 onto the square root of 6 is 8 onto the square root of 6. So on number 4, I've got 2 onto the square root of 5w plus 3 onto the square root of 5w. So our 5w's are the same under the radical, so that means we can go ahead and combine these coefficients. Again, the coefficient is what number you have in front of that radical. So we can go ahead and say 2 plus 3 is 5, and then we rewrite our square root of 5w. On number 6, I have 8 onto the square root of a minus 6 onto the square root of b. So on this problem, notice that we have an a under our radical in the first term and a b under the radical in the second term. Remember, the only way we can combine terms with radicals is if we have the same number under that radical, called the radicand. Since we do not have the same number, you can write one of two answers. You can either rewrite that expression, or you can say cannot be simplified. Either answer would be acceptable. So on number 8, I have 5 onto the 4th root of 3 minus 2 onto the 4th root of 3. One thing you might be wondering is, does the root matter, meaning the index? Yes, that does matter. If they do not have the same index, you cannot combine them, just like you have to have the same exponent when combining like terms. So for example, if we had, let's say, 2x to the 3rd plus 4x to the 4th, y'all would tell me we couldn't combine those because they don't have that same exponent. Same case here, but we have the same index, we have the same radicand, so we can go ahead and do the operation. So 5 minus 2 is 3, and then we rewrite it as the 4th root of 3. Please be careful to note that if you do not write that 4th root, that 4 in your index for your answer would be counted as wrong. So please make sure that you check that. And then finally on number 10, I've got 8 onto the square root of 3 plus 2 onto the square root of 3 minus 7 onto the square root of 3. So you notice that all of these terms have the same number under the radical. So I'm going to go ahead and just draw this fancy looking symbol here that indicates that I'm going to go ahead and do those operations first. So I'm going to add my 8 square roots of 3 plus 2 square roots of 3, which will give me 10 square roots of 3. And I didn't do anything with that minus 7 square root of 3, so I'm just going to bring that down. So now 10 minus 7 is 3, and don't forget your square root of 3. Now on number 12, it's a little bit different. I've got the square root of 27 plus the square root of 3. The directions say simplify the radical expressions when necessary, then add or subtract as indicated. So this goes back to section 7.2 when we learned how to simplify these radical expressions. So 27, we can break that down by using a prime factorization tree. I'm going to use the factors 9 and 3, and remember, each time you find a prime number, you circle it. And then my 9 breaks down to be 3 and 3. So now I can rewrite that as 3 times 3 times 3, and then plus the square root of 3. So one pair of 3's comes out because it's understood that there's a 2 in that index if it's not written. So a 3 comes out of the radical, a 3 stays under the radical, and then plus the square root of 3. Please be careful here to notice that the number understood to be in front of the square root of 3, if it is not written, is a 1. So in this case, we would add 3 plus 1, which would be 4, onto the square root of 3. So now we're going to move on to number 14. Number 14 is a very good indication as to whether you know what you're doing or not. I've got 2 onto the square root of 40 plus the square root of 90. So I have to simplify first before I can add. The reason is because I do not have the same number under my radical. So 40, I'm going to break it down as 4 times 10. Remember, you can use whichever numbers you want. You should still get the same exact answer I get. So I have 3 2's come out and 1 5 come out. So this 2 out front, I'm not going to do anything with it except for just bring it down. And then I'm going to replace that square root of 40 with those 3 2's and that 1 5. And then 90 breaks down to be 9 and 10, 3 and 3, 2 and 5. Again, if you wanted to use different factors, you could definitely do so. So if you would like to try and use the factors, let's say 2 and 45 or 3 and 30, go ahead and pause this video and break those down with a prime factorization tree and see if you get the same thing that I did, which you should. So I'm going to replace my square root of 90 with the square root of 2 times 3 times 3 times 5. So I had that 2, 3, 3, and 5. So I can take 2 out at a time. So again, this 2 is brought down, this 2 is brought down, and then my 2 times 5 stays in the radical. Then this 3 comes down, and remember they come out just as 1 3. And then my 2 and 5 stay under the radical. So what do we do with these 2's here? Well, this 2 is right next to the radical. So let's put this in the terms of having an x. If I had 2x, the operation that would be done to those is multiplication. So the same thing, if you've got a 2 next to a radical, that means your 2 is being multiplied by everything inside that radical. So when we pull this 2 out, that means we would multiply that by the 2 in front. So 2 times 2 gives me 4. 2 times 5 gives me that square root of 10. I'm going to bring down my 3, and that 2 times 5 gives me that square root of 10. So 4 onto the square root of 10 plus 3 onto the square root of 10 is 7 onto the square root of 10. Okay. Now let's move on to number 16. Number 16 says I have the square root of 108 minus the square root of 27 plus the square root of 75. So I'm going to do my prime factorization tree for every one of these. So 108, I'm going to use 2 and 54, 9 and 6, 3 and 3, and 2 and 3. So that 108 will be replaced with 2, 2, 3, 3, 3. Remember, everything that's circled goes under that radical. 27 is 3 and 9, and 9 is 3 and 3. That one was a lot shorter. And then 75 is 5. I'm sorry. That's not the factor I wanted to use. Is 3 and 25. Then 25 breaks down to be a 5 and a 5. So now that 75 is replaced with a 3, a 5, and a 5. So over here I can pull out a pair of 2's and a pair of 3's. So they come out as 2 times 3, and that 3 is left under the radical because it doesn't have another pair. This pair of 3's comes out, leaving this 3 under the radical, and this pair of 5's comes out, leaving that 3 under the radical. So notice we all have the same number under our radical. So I'm going to go ahead and multiply 2 times 3 to get 6, and then bring the rest of my problem down. So I can go ahead and combine these two to get 3 square roots of 3 plus 5 square roots of 3. So 3 plus 5 is 8. Bring down your square root of 3. Now let's look at number 18. Oops. On number 18, I have the cubed root of 16 minus the cubed root of 2. So 16 breaks down to be 4 and 4, and then those 4's break down to be 2's. And that 2 won't break down. It's a prime number, so there's nothing we can break it down to be. So I'm left with 4 2's under the radical. Remember, it's the cubed root minus the cubed root of 2. So in this case, 3 2's come out because our index this time is now a 3. So a 2 comes out, and I'm left with the cubed root of 2 minus the cubed root of 2. Now it might be really easy to get confused on this problem. So what I recommend doing is write that 1 there in front of that cubed root of 2 so you don't get confused. So now we can say 2 minus 1 is 1 onto the cubed root of 2, or I will accept just the cubed root of 2. Either answer is fine. Number 20 says I have the square root of 27p plus the square root of 75p. So my 27 breaks down to be 9 and 3, and then 3 and 3, which I now have 3 3's and a p. 75 breaks down to be 3 times 25. 25 breaks down to be 5 and 5. So I'm left with 3 times 5 times 5 times p. Now my index is understood to be a 2, so I can pull out 2 of a number at a time. So this 3 comes out, leaving me with 3p under the radical. This 5 comes out, leaving me with 3p under the radical. So 3 plus 5 is 8, and then onto the square root of 3p. Number 22 says I have the square root of 125y to the third and that's minus the square root of 20y to the third. So 125 breaks down to be 5 times 25, and 25 breaks down to be 5 times 5. Then 20 breaks down to be 5 times 4, and the 4 breaks down to be 2 times 2. So now I'm going to rewrite my radicals. I have 3 5's and then 3 y's minus, I've got 2 2's and a 5, and then I've got 3 y's. Make sure that radical extends the whole way through. I can pull out 2 numbers at a time. So that leaves me with 5y, and then that 5y stays under the radical, minus 2y comes out, and that 5y stays under the radical. So now since we have the same radicand, we can go ahead and combine our coefficients by saying 5y minus 2y is 3y, and then 5y is under the radical. Now to number 24. This one's going to be a little bit long and a little bit complicated, so just be ready. On number 24, I have the 4th root of 2z to the 7th. Yes, my z's are a little funky. I do that so it's a little bit easier to see, and it doesn't look like a 2 that way. Minus z onto the 4th root of 32 z to the 3rd plus the 4th root of 162 z to the 7. So the only thing I can break down over here are my z's. So I'm not going to really write that one just yet because I still have a 32 and a 162 to break down. So my 32 can break down to be 8 times 4. 8 breaks down to be 4 times 2. 4 is 2 and 2. Same with that 4. 162 breaks down to be 2 times 81. 81 is 9 and 9, and those 9s break down to be 3s. Next, I'm going to rewrite out what I have. So I have the 4th root of 2 times z 7 times. One, 2, 3, 4, 5, 6, 7, minus, I've got a z on the outside, and then there were 5 2s and 3 z's, and then I have plus the 4th root of, I have 1, 2, 4 3's, and then 7 z's. Now, if you remember the trick I taught you in section 7.2, you may remember that there's a trick you can do without writing all of those z's out. So if you would like to revisit that trick, please go back to that lesson. But the index tells me I need 4 of a number to release it from the radical. So I can pull 4 out for my z's. So 1 z comes out, leaving me with the 4th root of 2z to the 3rd, minus 4 of those 2's come out, and I have a z already on the outside, so we're left with 2 and those 3 z's inside. So that leaves me with the 4th root of 2z to the 3rd, plus 4 3's comes out, 4 z's come out, so that leaves me with 3z onto the 4th root of 2z to the 3rd. So next I'm going to combine these terms. So 1z minus 2z is negative z, and I'm going to write all that hot mess afterwards. And then I'm just going to bring down this whole term. Now I'm going to combine these terms. So if I've got negative z plus 3z, that gives me 2z onto the 4th root of 2z to the 3rd. So with that problem, that's the end of adding and subtracting those radical expressions. So now all we have left to do is multiplication, which is numbers 34 through 64. So on number 34, I have the square root of 10 times the square root of w. The rule is that you cannot multiply numbers or letters where one is inside and one is outside of the radical. So, in other words, you can only multiply two things if they are either both outside of the radical or if they are both inside the radical. So since the 10 and the w are both inside the radical, then I can go ahead and rewrite that as the square root of 10w. $36, I have 5 times 7 times 3, and that's all the square root. So the square root of 5 times the square root of 7 times the square root of 3, they're all under the radical, so that gives me the square root of 105. Now the directions do tell us to simplify each expression. I know I can't simplify that 105 because I just multiplied 5, 7, and 3 to get 105. So if I were to break this down using a prime factorization tree, these are the three numbers I would get, which are all prime numbers. So there is nothing we can break this down to be, because I would have needed at least two prime numbers to release them from the radical. Number 38, I have the cubed root of 5 times the cubed root of 7. They're both under the radical, so I can multiply them together. Just don't forget about that cubed root sign. Number 40, I've got the square root of 5 times the square root of 20. You may notice that the square root of 20 can be broken down and simplified. However, I do not recommend breaking it down first, because you might find yourself doing more work if you do it that way. So if I went ahead and multiplied 5 times 20, I would get the square root of 100. And we all know that the square root of 100 is 10. Because when you ask what the square root of 100 is, you're asking what number times itself gives you 100. So that number is 10. Number 42, I've got the cubed root of 25x squared times the cubed root of 10x squared. So I'm going to go ahead and multiply those together to get the cubed root of 250x to the 4th. So I'm going to break 250 down. I'm going to use 25 and 10, 5 and 5, and 5 and 2. So that can be broken to be 2 times 5 times 5 times 5. And then I've got those 4 x's. So I have to take 3 out at a time. So a 5x comes out, and I'm left with a cubed root of 2x. Number 44, I have the cubed root of 18 r squared s squared times the cubed root of 9r squared s. So to multiply those out, sorry about that, guys. So to multiply those out, I would go ahead, since they're both under the radical, that would give me 162 r to the 4 s to the 3. The reason is, when you multiply your bases, which are your r's, you add those exponents. So 2 plus 2 gave us that 4. And then you're also multiplying these s's. Well, this s has an exponent of 2, but this one isn't written. If the exponent is not written, it's understood to be a 1. So 2 plus 1 is 3. So now I break down 162. And I'm left with the cubed root of 2 times 3, 3, 3, and 3. And I'm not going to write out my r's and my s's this time, because we knew a shortcut back in section 7.2. So I can pull out these 3's. So 1 3 comes out. And we can say that we can divide the index into the exponent of the variable. So 3 goes into 4th 1 time. So 1 r is released. And there was 1 still left over. So that r to the 1st stays inside. And then 3 goes into 3 1 time, meaning that an s to the 1st comes out. And there was no remainder, so no s's come out. So this is our final answer. Now you do not have to write these, oops, Oops, sorry guys. Forgot one little bit of information. Don't forget that you have this 2 times 3 here, which would have given us a 6, and then that r. So if you don't write these 1s up here for your exponents, it's not that big of a deal because it's understood to be a 1. So now we're going to look at number 46. I've got the square root of 3 times the square root of 5 minus 7. And again, that's number 46. So this problem hopefully looks a lot like the distributive property. So that means we're going to multiply that square root of 3 times everything inside of that parentheses. So since the 3 and 5 are both under the radical, then we can multiply those together to get the square root of 15. But the 7 is not under the radical. So what we would do is we would say, well, the square root of 3 times negative 7 is negative 7 square roots of 3. Just like if I had x times y minus 7. When you go to multiply the x times the negative 7, it would be negative 7x. This is the same concept here. The 15 and the 3 won't break down at all. They're not the same radicand, so we are finished. 48 is another one of those problems where if you can do it, you know you have a really good understanding of how to work these. So I've got the square root of 2 times the quantity 2 square roots of 10 plus the square root of 40. Remember, I said do not simplify until after you've multiplied everything else. It'll end up saving you a little bit of time. So I'm going to multiply this square root of 2 times the first term and the square root of 2 times the second term. So the square root of 2 times 2 square roots of 10. Okay, imagine there's a 1 in front of that square root of 2. Well, you multiply what's outside of the radical with what's outside of the radical. So 1 times 2 is 2. And then you multiply the square root of 2 times the square root of 10, which gives me the square root of 20, plus square root of 2 times square root of 40 is square root of 80. Now all I have to do is simplify and then see if I can add. 4 and 5, 2 and 2, 8 and 10, 4 and 2, 2 and 5, and then 2 and 2. So now I'm going to rewrite this. I'm just bringing that 2 down, and then I'm rewriting my square root of 20 as 2 times 5, and then I'm rewriting my 4 2's and my 5 in place of my square root of 80. So I only need 2 of a number to release it from the radical. So this 2 comes out, and then I have these 2's that come out. So again, I'm going to bring this 2 down. These 2's come out as 1 and they come down, and I'm left with the square root of 5 plus these 2's come out. I'm left with that 5. Remember, these 2's that come out are being multiplied. So that gives me 4 square root of 5 plus 4 square root of 5, which is 8 square root of 5. So on number 50, I have the square root of y times the square root of 8y minus the square root of 2y. So I'm going to distribute. So my square root of 8y squared minus the square root of 2y squared. So my 8 breaks down to be 4 and 2, and my 4 is 2 and 2. So I have the square root of those 3 2's and that y squared minus square root of 2y squared. Now I didn't break up that 2 because it's already a prime number, so there's nothing that I can break that up to be. So this 2 comes out, and then a pair of y's come out. So I have 2y onto the square root of 2 minus y onto the square root of 2. Remember that this y has an understood 1 in front. So 2 minus 1 is 1, y square root of 2. I would accept that, or I would have accepted just y onto the square root of 2. Number 52, I've got the cubed root of 6 times the cubed root of 22. I'm sorry, the cubed root of 32. I'm sorry about that. Minus the cubed root of 4. So I can distribute, which gives me the cubed root of 192 minus the cubed root of 24. So 192 breaks down to be 6 and 32. 6 is 2 and 3. 32 is 8 and 4. And just keep going. Y'all should be professionals at this by now. And then 24 is 6 and 4. 2 and 3, and then 2 and 2. So to rewrite this, I would have the cubed root of, well, let's count. 1, 2, 3, 4, 5, 6 2's, and then 1 3. Minus the cubed root of, I've got 3 2's and then 1 3. This still looks like a 3. Let me change that. So I need 3 of a number to release it from the radical. So I can take out these sets of 2's and this set of 2's. So these 2's come out, and remember they're being multiplied by each other, and this 3 stays under the radical, minus this 2 comes out of the radical, and the 3 stays under. So 2 times 2 is 4. So 4 minus 2 gives us 2, and then we have the the third root of 3, or the cubed root. So on number 54, number 54 says I've got the square root of 3 minus 1 times the square root of 3 plus 5. This is also your distributive property. You multiply the square root of 3 times everything in that second set of parentheses, and then your negative 1 times everything in this second set of parentheses. So let's start. Square root of 3 times square root of 3 is the square root of 9. Square root of 3 times 5 is 5 square roots of 3. The reason is because that 5 is not under the radical and the 3 is, so the 5 is just placed in front. Negative 1 times square root of 3 is negative 1 square roots of 3. Negative 1 times 5 is negative 5. So now I can do a couple different things. I'm going to go ahead and take the square root of 9, which is 3, and I'm going to combine these terms. So 5 minus 1 is 4, and I have the square root of 3, and I'm going to bring down the minus 5. Notice we still have like terms there. We can still do 3 minus 5, which is negative 2, and then you bring down that 4 onto the square root of 3. Number 56 says I have this, hold on. Okay, I want to make sure I did 54. Sorry about that, guys. 56 is the square root of 6 minus 2 square root of 3. And then the square root of 6 minus 3 square root of 3. Same thing, I'm going to distribute that square root of 6 times every term inside of the second set of parentheses, and then my negative 2 square root of 3 times everything in that second set of parentheses. So square root of 6 times the square root of 6 is the square root of 36. The square root of 6 times negative 3 square root of 3. So you've got to look, the 6 and this 3 are both under the radical, so you multiply those together. So you just bring down the negative 3 in front, and then this 6 times this 3 is the square root of 18. Then negative 2 square root of 3 times square root of 6 is the same thing. The negative 2 stays on the outside, and then the 3 and the 6 multiply because they're both under the radical. And then negative 2 square root of 3 times negative 3 square root of 3 would be positive 6, because negative 2 times negative 3 is 6. Square root of 3 times square root of 3 is the square root of 9. Now the square root of 36 is 6. If I combine these middle terms, I get negative 5 square roots of 18. And then the square root of 9 is 3. So I'm just going to bring down that 6. And then the square root of 9 is 3. So the next thing I need to do is combine those by multiplying. So that gives me 6 minus 5 square roots of 18 plus 18. Now I can combine my 6 and my 18 to get 24 minus 5 square roots of 18. And then finally I can break down that 18 to be 9 times 2. 9 breaks down to be 3 and 3. So I'm left with 24 minus 5 onto the square root of 2 times 3 times 3. So a pair of 3's come out, and I'm left with 24 minus 5, and then that 3 comes out, square root of 2. 5 times 3 gives me 15. So my final answer is going to be 24 minus 15 onto the square root of 2. Now on number 58, we have the square root of 10 plus 2 times the square root of 10 minus 2. So you will notice that these problems here they're conjugates of each other. Whenever you have a conjugate, that means that you have the same terms inside of your parentheses, but the only difference is that one of them is positive and one of them is negative. That's the only difference, okay? So the square root of 10 times the square root of 10 is the square root of 100. Square root of 10 times negative 2 is negative 2 square roots of 10. 2 times the square root of 10 is 2 square root of 10. 2 times negative 2 is negative 4. Remember, the reason I didn't multiply this 10 and negative 2 to get negative 20 is because the 10's under the radical, the 2 is not. So then what you should notice is that these two terms are going to cancel out, leaving us with the square root of 100 is 10. Bring down your minus 4. So 10 minus 4 is 6. Now number 60 says I've got the square root of m plus the square root of 7 times the square root of m minus the square root of 7. So again, this is called a conjugate. So the square root of m times the square root of m is the square root of m squared. Square root of m times negative square root of 7 is negative square root of 7m. And since they were both under the radical, we went ahead and put them both under the radical. And the square root of 7 times the square root of m is the square root of 7m. Square root of 7 times negative square root of 7 is negative square root of 49. So notice again is that these middle terms cancel out. So you might notice that between number 60 and 58 that we just did, when you multiply conjugates together, you will always notice that those middle two terms are always going to cancel. That's only when you're multiplying by conjugates. So the square root of m squared is m minus, because of that minus there, and the square root of 49 is 7. Number 62 says I have the square root of 5 plus the square root of 2 squared. Okay, this problem can be tricky. Sometimes you may remember that you would just square the square root of 5 and the square root of 2, but that is not the case. The reason you can't do that is because of that plus sign. So what we have to do is we have to actually rewrite the square root of 5 plus the square root of 2 2 times. And then we would distribute like we've been doing the whole time. So that gives me square root of 5 times square root of 5 is the square root of 25. The square root of 5 times the square root of 2 is the square root of 10. The square root of 2 times the square root of 5 is the square root of 10. Square root of 2 times the square root of 2 is the square root of 4. Notice that there are understood ones in front of those square roots of 10s. So when we work this, the square root of 25 is 5. 1 square root of 10 plus 1 square root of 10 is 2 square root of 10. And then the square root of 4 is just 2. So to finish up, we will combine our 5 and 2 to get 7 plus 2 square root of 10. If you wrote down 2 square root of 10 plus 7, that is fine. I will accept that answer as well. All right, so number 64 says that I have the square root of x minus 4 squared. So I'm going to rewrite this as the square root of x minus 4 times the square root of x minus 4. Now I recommend you try working this problem without watching me teach it, just to see if you can get it right. So if you would like to do that, go ahead and pause the video now. So what you should have done is distributed just like we've done on every other problem. Square root of x times the square root of x is the square root of x squared. Square root of x times negative 4 is negative 4 square roots of x. Sorry, it's getting kind of hard to see. I'm running out of lead. Then I have negative 4 times the square root of x is negative 4 square root of x. And then negative 4 times negative 4 is that positive 16. So now the square root of x squared is x. And then to combine these terms, negative 4 minus 4 is negative 8. And don't forget about your square root of x. And then bring down your 16. And there are no terms that you can combine there. So we are actually finished with this problem. All right, the final problem we have to do in this section is number 66. I've got the square root of r minus the square root of s squared. So I can write that as the square root of r minus the square root of s times the square root of r minus the square root of s. So I'm going to distribute. Which gives me square root of r times the square root of r is the square root of r squared. Square root of r times negative square root of s is the negative square root of rs. Then the negative square root of s times the square root of r is the negative square root of rs. And the reason I wrote rs instead of sr is because they should always be written in alphabetical order. And then the negative square root of s times negative square root of s is the positive square root of s squared. Remember, as stated earlier, there are understood ones in front of those square root of r's. So the square root of r squared is r. Negative 1 minus 1 is negative 2 square root of rs. Bring down your plus sign. The square root of s squared is s. There are no terms that we can combine. There's nothing else that we can break apart, so we are now finished. Again, with dividing, which is objective 3 on page 585, we are not going to do that in this lesson. We've already covered that in the rationalizing the denominator lesson. So if you would like to see those, please turn to that section. I hope this has been helpful to you, and good luck.